Hello everyone. The questions in this video have to deal with absolute value and the graphs of those absolute values, the translations of the absolute values. So we're going to get right to it. Number one, we're just going to go and use the calculator. Remember, always use your calculator to graph and to get those coordinates. So we're just going to go and press y equals, and we are going to graph f of x equals, let me move my face over here, the absolute value of x plus 1. There's a couple of ways to get to absolute value on the graph, on the graphing calculator. And the one way that I am going to show you is that you could press math and num. And you go to the right, and right there is ABS. And you just go back to the main screen, and not the main screen, the y equals screen, and you put your x right directly in the middle of those absolute value bars, and plus 1 is on the outside. When you press graph, you'll see that an absolute value graph is a V, is in the shape of a V, and that'll always be the case. So when you press second function graph, we will get coordinates, and I always go all the way back to the -9 coordinate or -10 because I know this left side is -10. So when you have -9, 10, it is 9 to the left and 10 up, and you are going to plot that point, -9, 10, and then you're going to go -8, 9. -8, 9 is right here. And -8, 9 is right there. -7, 8 is right here. And you will follow that pattern down all the way. And you have to look, 0, 1 is the y-intercept at this point right there. And then I'm going to go and press down, and I'm going to get some more coordinates just to check to see if everything is exactly how I think it is. It's 1, 2, so 1 to the right and 2 up. And then 2, 3, which is here. And then you go and go quickly because the pattern is the same. And you grab your ruler, connect those points, go past the last point. You see that last point? That was a mistake on my end. You put arrows, and then you label the line. If it's f of x equals the absolute value of x plus 1. And what that does is that it actually translates the graph up 1. And you can see that right here is 0, 0. Right there is the origin. And it would go up 1 because that plus 1 acts like a y-intercept. So we're going to talk about f of x, this one right here, f of x equals the absolute value of x minus 1. So we're going to press y equals, clear that out. And the other way that I wanted to show you to get to the absolute value on this calculator is that you could press second function and 0, second function catalog, and it'll bring up the catalog screen. You see the ABS there, you just press enter and you're good to go. So it's x minus 1 that goes inside the absolute value bars, and then you press graph. And this one moves to from 0, 0, moves to the right one. So we're going to press second function table just to get some coordinates. And we're going to go all the way up to -9. So -9 would be, let me just move this over just a little bit more. -9 would be -9 to the left and then 10 up. And then -8, 9. like that. And then you're going to follow the pattern down just like I'm doing here. Again, I want to go to the y-intercept of 0, 1, and that is a good y-intercept. We have 1, 0, which is right here, which turns out to be the x-intercept. And then we're going to follow 2, 1. It kind of goes up again, so that's where the v is, that point. And then 3, 2. And then we're going to go and continue on with the pattern just like that. Looking at that pattern, we're going to have now, we're going to connect those points. Go a little bit beyond those the last point on each side. Put the arrows on each side and then label f of x equals x minus 1, the absolute value of x minus 1. Just remember, when the number's inside the absolute value, it acts the opposite way of what you think it's going to do. It is always, the x minus 1 is usually to the left, right? It's 1 to the left. But that is not the case when it's in absolute value. It goes to the right. So you would think it would go to the left, but again, it's opposite because it's in that absolute value. Number 3, we're going to take the calculator, graph it, and I'm going to go second function 0. And then there's the ABS, the absolute value. We have x minus 3 inside the absolute value bars, and then plus 2. So we're going to graph that, and you can see that that moves to the right 3 and up 2. That's exactly what the translation is. So we're going to have second function graph, and we are going to pick the negative 5, 10, negative 5 to the left, 1, 2, 3, 4, 5, and 10 up. And then negative 4, 9 is here. Negative 3, 8. And you go on to 0, 5, which is right there. That's the y-intercept. 1, 4. 2, 3. And then 3, 2. And then we're going to go down and we're going to see if this thing starts turning around or going back up, I should say. So 3, 2 was the last point that I graphed, and then 4, 3. So 4, 1, 2, 3. There it is. And then 5, 4. And then you don't have to look at the calculator anymore. That is the pattern. And we're going to connect those points after you're finished. Arrow on this side, and arrow on this side. This is f of x equals absolute value inside x minus 3, and then plus 2 on the outside. The last one that I am going to graph is this one right here, and there's a lot going on with this one. See that negative outside? Let me get this to the biggest that it could possibly be. So this is y equals, get this, stretch this out, and we're going to clear that out. And just remember, when you put a negative outside of the absolute value bars, you have to put the negative in first. Then you could go second function 0, and there's the ABS. And when you go back to the y equals, notice the negative is outside. Then you're going to press x plus 3 for this particular one on the inside of the bars, and then minus 2 is on the outside. So then you press graph, and you can see that this is an upside down, facing down. The v is facing down, your second function table, and it's facing down because there's a negative absolute value, the negative is on the outside. So if it's negative 10 and negative 9, which is down here, negative 9, negative 8, which is here. And then we're going to just go up just like this. And then just make sure that you are, I am up to negative 4. So negative 4, negative 3, which is here. Negative 3, negative 2, which is here. And then negative 2, negative 3. See how it goes back? Like down in this case, back down. That is 1, 2, 3, 4, 5. So 0, negative 5 is correct. I'm just checking to see on my calculator that I did everything correct. So then we have 1, negative 6. And then we're going to go and finish it off right here. So we have to connect our points. Remember, don't forget to put the arrows on each end because it goes on forever in both of those directions. Then you, well, I almost put f of x, which it's y equals, should be f of x, is negative absolute value of x plus 3, and then minus 2. So the x plus 3 moves it to the left 3, and then goes down to the negative 2 on the outside. The minus 2 makes it translate down 2. And that is it. So this is called right here, y equals the absolute value of x. That is called the parent function. And the parent function is something that everything is compared to. So if you want to put the parent function in, you have second function catalog and then enter. And you have x right in the middle of the absolute value. And if you press graph, you could see that there is a v. And that v actually meets right there. It comes to a point at 0, 0, which is the origin. That is called the parent function. So everything is compared to that parent function. Everything. So the word translation, I just want to make sure that you understand. Translation is a move or shift. So the parent function is going to move or shift, right? So let's just take a look at A. We're going to have to write the equations down. They do this a lot and they ask this a lot. So if you're going left 7 units, we're just going to have y equals, and this is compared to the parent function of the absolute value. So an absolute value that shifts left 7 would have an absolute value bar and an x and then plus 7. And again, I always think of it as plus 7 is going to the right, but it's not because it's inside the absolute value, so it's going to the left. Now we're going to go up 2 units and write 3 units. So it gets a little bit more difficult. So we're just going to put y equals. We're going to put the absolute value, x, and then I'm going to take the right 3 units and do minus 3 inside. Then up 2, that's a plus 2 on the outside. Again, you could put these into your calculator and you could figure out exactly if that is correct. So if we put these in, if I put this into the calculator, that's the parent function. And now I'm going to move down and then put, so I needed to go 3 to the right and 2 up. So x minus 3, second function 0, and then enter, and then x minus 3, and then plus 2. So look, this is what I had down, and I'm going to check it on the calculator that it does go up 2 units and write 3 units. So I'm going to press graph and look at the first function, and then look at the red. That's the second function. This blue is the parent function. So to the right 3 and up 2. And that's going from 0, 0 to the right 3 and up 2. So I am correct in writing that. Right? Again, you could do that for every single question. So right 2 units is y equals. We're going to go right, which is minus. And that's it. And you could check it in the calculator as well. Now, circle which is the graph of y is the absolute value of x plus 2. Don't ever get any of these incorrect because, again, you have your calculator. Your calculator could tell you exactly which graph, what it looks like, but I'm just going to look at the graphs and I'm going to pick the answer based on what I know about graphing. So this is a upside down U shape. This is an exponential graph. That's an exponential graph. So if it's an exponential graph, it is a U shape. Exponential function. I shouldn't say graph. I really should say function. And that was bothering me as soon as I wrote it. This right here is a straight line. So you have to know that that is a linear function. It's a graph of a linear function. And you know that it has to be in y equals mx plus b. This has a negative slope, and it also crosses at this right here, this y-intercept of 2. So that is nowhere near what the answer is. So that's out and that's out. Here's another exponential function. Again, it's another U shape. This is an exponential function that faces downward. So this is a negative exponential function. This is a positive exponential function. So we get up to the last one. This is out as well. And this is your answer. And the reason why that is your answer is because it's a V shape. V shape is an absolute value graph or function. So the absolute value is inside. It makes it a V shape, and then plus 2, it goes up 2. Translates up 2. And that's basically it. Circle a graph that this is the equation of. Y equals the absolute value of x minus 2. So when you're looking at y equals x minus 2, you're looking at the x and minus 2 inside the absolute value. So if it is, you would think it goes left 2, but it goes right 2. So the minus 2 is right 2 from the origin, from the parent. This is up 2. That is not the graph. That's going up 2, and that right there is not the function. Right? This goes right 2. This is it. This is left 2. That's out. And this is a V shape that goes down 2. And that's out. And I just put all of the actual equations down of each function. So this one would be y equals the absolute value of x plus 2. This one would be the actual answer, y equals the absolute value of x minus 2 inside. This is going left, so it's x plus 2. And this one goes down, so this is y equals absolute value of x minus 2. And that is that. So which equation represents the function shown in the graph? This is going up 1. If it goes up 1, we have y equals the absolute value of x, and it's plus 1 on the outside. So absolute value of x plus 1 is number 1. This goes down 1. So that's out. This one will go to the left 1. and this one will go to the right one. And again, you could put all of these into your calculator and you could figure out exactly which one it is. So the absolute value function is the absolute value of x, and we have that graphed right here. So I usually leave it in, but if you find it confusing to look at two graphs, you don't have to leave it in. So I'm just going to go ahead and graph this. This is the y equals the absolute value of x plus 2, and the absolute value of x plus 2 is inside the absolute value. So I'm just going to get to the absolute value. The x plus 2 is inside, and then I'm going to go to the right to get it outside. So just when I press graph, you could see the parent function versus the other function that I just graphed. So this is moving to the left from the parent function. It moves to the left too. So the transformation moves to the left 2. And you could say units. And the type of transformation it is a translation. So if you want to use the word translation, that will probably be better. It's a translation to the left 2 units. So here we go. I'm just going to go ahead and graph this because this one's a little bit tough. The negative is on the outside. The absolute value of x is in the inside, and then it's plus 7. So I'm just going to go to y equals. I'm going to go down to y2, and I'm going to put the negative in first. Then I am going to press second function catalog and then enter. And then there's the x that I'm going to need. I'm just going to check to see exactly what I have. And then the plus 7 is on the outside. So it's pressing to the right, and you put plus 7. Now you go and look at what the graph is doing. The blue absolute value graph is the absolute value parent function. The red is what your function for number 2, that's the function that you have to describe. So now it faces downward, it reflects downward, and then it moves up 1, 2, 3, 4, 5, 6, 7. All right. So transformation is that it reflects down and moves up 7 units. And you could put translates Okay, so here we go. I'm not going to do this with the calculator anymore. I'm just going to put down exactly what I see. Absolute value of x minus 3 on the outside. So the absolute value of x is that this one moves down 3. Think of this as the y-intercept. So this translates down 3 units. And that's it. Number 4, this is inside x minus 9. So this translates right 9 units. Or 9 units to the right. This one right here, a little bit difficult, but take it one step at a time. It translates two units to the left. And then down 3. And that is it. So these are more questions that you have to write the equation. Again, just describe what is happening from the parent function. So absolute value, we're going to have an absolute value graph. Up 7 and left 3. So we're going to do left 3 first, and that is plus 3. And then up 7 is plus 7. Again, you could check on your calculator. The absolute value, y equals down 4. Down 4 and right 1. We're going to do the right 1 first. So it's x minus 1. And then down 4 is minus 4. Absolute value, right 6. So opposite. X plus 6 is what you'd think it would be. But since it's inside the absolute value, it is minus 6. Right 9 and 2 down. So we have y equals right 9. We're going to talk about what it is to go right is minus 9. And then down 2, minus 2. Number 5, we're going to have the left 6 and reflects upside down. So reflects upside down is a negative on the outside. So the absolute value bars, to go left 6, that's x plus 6. And the negative makes it upside down. Right? And then number 6 reflects up. All right, so it reflects. So it reflects. That means if it's according, like the parent function is up, so it reflects, that means it's going down. So that means the first thing that I'm going to put is y equals and the negative. So up 2 and left 9. So if you're talking about left, you're talking about plus 9. And then up 2 is plus 2. So as always, just check it on your calculator, right? No matter what you do, you put it into the calculator. Know that if you have a negative outside the absolute value, if you have negative right before it, that you have to put that negative in before you go to the absolute value to put the absolute value into the calculator. So just remember that the negative means that it reflects. All right. So if you're talking about a parent function of y equals absolute value of x, and then there's a negative outside for y2, you know that you're going to have an absolute value that is reflected down now because it's a negative absolute value. And that's it. Every single time that you do this, though, especially for the regions, make sure that you have your calculator beside you and you're putting in each one. If you know the answer, if you think you know the answer, that's not good enough. Check it on the calculator after you circle it. Make sure, because this is an easier topic that your calculator could give you the answer to. All right. So that's basically it. That ends these questions. Thank you for watching. Hope that helped. See you next time.